It is a unified phenomenon in my view. Despite the fact that we have nuclear effects and we have heat effects, you really have to look at it in a unified way. But this is how various people look at this problem. Some say that there's nothing there, like Taubes and, all right, not Goodstein. Goodstein will give, he wrote an essay in the American Scholar magazine in which he gave some possibility that it was real, but not very much, okay? Just because his friend Franco Scaramuzzi of Italy, good friend of his, is getting some positive cold fusion results. Therefore, that's the good cold fusion, he says. Everything else is the bad cold fusion, which is kind of unbelievable philosophical confusion, I think. And Huizenga, who says this is all pathological and close and so forth. All right, let's move up from this nonsense, which is, of course, what that is, and get into the realm where people say, well, there are some interesting nuclear effects. Like Steve Jones was in that mode for a while. And he said, well, I see neutrons and maybe tritium, but I don't believe this heat stuff, you know. The heat is way out of order compared to the products. It just doesn't make sense. The heat doesn't make sense. It's probably a mistake. Then there were some people who just believed in the heat and not the nuclear products. And then there were some people who believed that they were both there, but that they were unrelated, which violates what I know of Occam's razor. Simplifying theories. Doesn't mean that they couldn't have been separate, but I just don't believe that it was a likely possibility. They're unified. It doesn't mean that the nuclear products explain the heat one-to-one. Let's get that straight. They're related, in my view, but they don't necessarily have to be commensurate nuclear products. In fact, they probably are not commensurate in general. That's the vast mystery of cold fusion. But as to their relationship, that is the thing that is causing the heat, also being involved in, which is a miracle in itself, the excess power, okay, also being related to nuclear products, come on, guys. I mean, it's just, it has to be almost. All right, it's possible that it isn't. Two things existing together that have nothing to do with one another. I just don't believe it. Anyway, we need proof of these assertions. We can't just pontificate about them like the physicists do who say that there's nothing there. Well, these are the explanations. This one, which we've talked about, some unknown chemical or mechanical phenomenon. Absolutely impossible if you believe the measurements. You cannot store that kind of chemical, ordinary chemical or mechanical energy. It is like the idea of storing a stick of dynamite in water. It just doesn't work, in my view. Nuclear reactions, we would call this the mainline cold fusion dogma. There is a dogma, okay? It's funny how human cultures act. Even the cold fusion people have their hierarchies. There are the conservative, fuddy-duddy cold fusion people who say it must be a nuclear reaction. Can't be zero-point energy, can't be anything else, can't be shrinking hydrogen atoms, can't be Professor Johnson's theories of Jahn-Teller bonds. It must, dynamic Jahn-Teller bonds, it must be mainline nuclear. One-to-one, we will find the commensurate products. Peter Hagelstein, a great friend of mine, wonderful man, he feels it that way. Neutron transfer reactions, you'll hear his view. He thinks he's absolutely right, just like Randall Mills of Pennsylvania thinks his shrinking hydrogen atoms is right. One thing you learn in cold fusion is that every preeminent theorist is absolutely convinced that their theory is correct. That is one of the most amazing phenomena. Well, actually, it was an obvious phenomena, but it's true. Then we have this one here, something else even more wonderful, and that these are auxiliary. That's the horse I'm betting on now, in a little bit of combination with this. Okay, this is out and that's out. That's the playing field, in my view. Or it can be a combination of things. It would have been very presumptuous in the early days of the field of chemistry to say, oh, chemistry is burning carbon. That's chemistry. There's nothing else. Just burning carbon is chemistry. No polymers, no buckyballs or anything else. We discovered the whole iceberg of chemistry. It took a long time. The same thing will happen with cold fusion, I'm sure. What would it take to get rid of all this? The exceedingly improbable determination that systematic errors have been made by dozens of researchers in half a dozen or more measurement areas. in each of which diverse experimental techniques have been applied. In other words, many different experiments, many different ways of measuring in each type of experiment. When you get all this multiplicity, my friends, you're talking about a near certainty. That's the basic reason to believe it. In the early days, there was every reason not to believe it, which is why I didn't believe it. Okay? I didn't believe it for sure. I mean, I felt it was worth pursuing, but I didn't believe it for sure. It took me a year, at least, to come to that conclusion, whereas the negative people would accuse me and my colleagues of saying that we became true believers on day one. That's not true. It was a very difficult path we followed. Now let me review some experimental evidence, just very briefly, because we're really pushing the time envelope, but I hope this will be helpful to you. Cold fusion is very often thought of as not repeatable. Well, here's an experiment that you can actually buy. I don't think they'll really demand 100K from you now, but that was when their ad. And the eQuest Sciences people in California can repeatably generate massive amounts of excess heat in the tens to hundreds of watts range, we believe. We would like to see more data from them. But one thing that appears to be nearly certain now, kind of reverse from the usual cold fusion, where you are certain about the heat, very certain about the heat, but less certain about nuclear products. In this case, they have got massive helium-4, 552 parts per million measured at tests done at Los Alamos National Laboratory and actually tested and analyzed at Rockwell International, okay, in California. Plus or minus 1 part per million, okay? That's 100 times atmospheric, and there was no entrance of the atmosphere to this experiment. The background argon cover gas was only 0.4 ppm, and they have 552 parts per million, plus or minus 1 part. EPRI spent $4,000 to have that data tested. And as far as I'm concerned, it's case closed. I know that Tom Passel thinks it is, of EPRI, and I do. And besides, they've gotten it over and over again at different levels, admittedly, but tens of ppm, and it's not with gamma radiation. So there's something very extraordinary happening there. The other thing they are getting is transmutations on the surface of the melted palladium. They have to be careful not to melt it. They melt it underwater very easily, under heavy water. Jim Griggs of Hydrodynamics will be talking about his hydrosonic pump, which works every time. It either produces hot water or steam, and he never intended to be in the cold fusion field. He just fell into it because he saw the Popular Science cover story, called Jed Rothwell and myself in. We evaluated it in our own method. We felt that he had a solid experiment. Others have come in and made it even more solid. It seems, in my view, proved, and Jim will tell you why later, that that system produces excess power on the order of kilowatts. Kilowatts of excess heat. And I have every reason to believe, and I won't go into all those reasons, but there are a number of reasons beyond this that suggest that it can be made much, much better. Yeah, after all, he never tried to optimize it, so why should it be that good? Okay? He just lucked out. Wonderful man that he is in designing that system. He didn't just do it by pure luck, but I'm saying he didn't intend to have an over-unity machine. He just happened to fall into his lap. But he can sell these machines anyway for very many other reasons that are very, very important. Here's another guy who's got helium, Dr. Melvin Miles of China Lake, and 3 sets of experiments from 1991, 92 to 93, and he's done the probability that all the experiments came out with the helium, the slight helium that he had, matching up with the excess heat versus the cases where there was no helium, essentially no helium, and no excess heat. The probability of that match, that coming out by random chance, just a complete fluke and an experimental error, is 1 out of 134,217,730.